An explanation of how gravity works in the universe. Gravity is one of the four fundamental forces of nature, alongside electromagnetism, the strong nuclear force, and the weak nuclear force. It is the force that governs the behavior of matter in the universe, from the smallest subatomic particles to the largest structures such as galaxies and clusters of galaxies. At its most basic level, gravity can be thought of as the force that attracts two objects with mass towards each other. The greater the mass of the objects and the closer they are to each other, the stronger the gravitational force between them. This is described by Isaac Newton's law of universal gravitation, which states that the gravitational force between two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. F equals g m1 m2 r squared. Where F is the gravitational force between the objects, g is the gravitational constant, a fundamental constant of nature. m1 and m2 are the masses of the objects, and r is the distance between their centers of mass. The force of gravity is always attractive, meaning that it pulls objects towards each other. This is why objects fall towards the ground when dropped, and why planets orbit around stars. In fact, the gravitational force is so strong that it can overcome the other fundamental forces of nature, such as electromagnetism, and bind entire galaxies together. The origin of gravity is still not completely understood, but it is believed to arise from the curvature of spacetime caused by the presence of mass and energy. This idea is described by Albert Einstein's theory of general relativity, which revolutionized our understanding of gravity in the early 20th century. According to general relativity, massive objects like planets and stars warp the fabric of spacetime around them, causing it to curve. This curvature affects the motion of other objects that are nearby, causing them to follow curved paths that are determined by the distribution of mass and energy in the universe. In essence, gravity is the result of the curvature of spacetime caused by the presence of matter and energy. One of the most interesting consequences of general relativity is the existence of black holes, which are regions of spacetime where the curvature becomes so extreme that not even light can escape. Black holes are formed when massive stars run out of fuel and collapse under their own gravity, creating a singularity, a point of infinite density and zero volume, at their center. Despite their name, black holes are not empty spaces. They have a mass and a gravitational field just like any other object, and they can affect the motion of other objects around them. In fact, black holes are believed to play a key role in the evolution of galaxies, as their powerful gravity can influence the behavior of stars and gas within them. In addition to black holes, gravity is also responsible for many other phenomena in the universe, such as the formation of galaxies and the expansion of the universe. The gravitational force between galaxies causes them to cluster together, forming large structures known as galaxy clusters. At even larger scales, gravity is thought to be responsible for the formation of superclusters, which are groups of galaxy clusters that are gravitationally bound together. On the cosmic scale, gravity is also responsible for the expansion of the universe. According to the Big Bang theory, the universe began as a tiny, hot and dense point about 13.8 billion years ago. Since then, the universe has been expanding, and this expansion is believed to be driven by the gravitational force between all the matter and energy in the universe. In summary, gravity is a fundamental force of nature that governs the behavior of matter in the universe. It is the force that attracts two objects with mass towards each other, and its strength depends on the mass of the objects and the distance between them.